Uh, this is a video about the CSCC matrices that I discovered, and I just want to go over some of the aspects of them because I think they're really fascinating, if for nothing else than just recreational math, I guess. But I believe there's more to them than that. And the reason I call them CSCC is because you have the C, the large cube, the three slabs, these slabs here that are adjacent and at a corner to each other. Then you have these three columns. You can call them rows, but columns are, I don't know, they're adjacent to each other at a corner. And then you have the last C, which is the smaller cube, which is the output number. These are the input numbers. And this larger cube, it transitions through these slabs and then into these columns and then into this output cube, the smaller cube. And this is how it goes. And I'll try to construct one in real time before this is over. Like, okay, here's how it goes. 1 plus 1 is 2. 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 Also, 1 plus 1 is 2. 1 plus 1 is 2 on this slab. 1 plus 1 is 2 on this slab. 1 plus 1 is 2 on this slab. Also, 1 plus 1 is 2 on this slab. 1 plus 1 is 2. 1 plus 1 is 2. 1 plus 1 is 2. Now, 2 plus 2 is 4 on this column, back column. 2 plus 2 is 4 on this back column. 2 plus 2 is 4 on this column. 2 plus 2 is 4 on this column. And 2 plus 2 is 4 on this column, top and bottom. And the resulting number is 8. And what I find interesting, one of the many things I find interesting, is that every single one of these groupings all add up to the output number. 4 and 4 is 8. 4 and 4 over here, and 4 and 4 over here, they're all 8. 2, 2, 2, 2 for this back slab. 2, 2, 2, 2 for this front slab. 2, 2, 2, 2 for this bottom slab. They're all 8. And lastly, 1, 1, 1, 1, 1, 1, 1, 1. They're all 8. I think that's interesting. I think that's really interesting to me. I'll go over another one. This has 36 as the output number. You have 6, 3, 36, 36, 6, 3. They equal 9, 9, 9, 9. They equal going across 9, 9, 9, 9. And these other slabs, 9, 9, 9, 9, 9, 9, 9, 9, which comes out 18, 18, 18, 18, and 18, 18, which they all converge to here, which is 36. And you'll find that 18 and 18 is 36, 18, 18 is 36, 18, 9, 9, 9, 9 is 36, and 6, 3, 3, 6, 6, 3, 6, 6, 3, they're all 36. These are the input numbers. You can put any numbers in here in any order. They don't have to follow any certain order. You can just throw any numbers in there, and they don't have to be just 8. They don't have to be just 8 numbers to each, one number to each corner. I'll show you in a second. But these are another 8 numbers to a corner, or one number to each corner. And these are all the same. 1 and 2 is 3, 5 and 6 is 11, 3 and 4 is 7, 7 and 8 is 15. But it's also 1 and 3 is 4, 5 and 7 is, or 2 and 4 is 6, 5 and 7 is 12, 6 and 8 is 14, and they're also this way. 1 and 5 is 6, 3 and 7 is 10, 5 and 6 is, or 2 and 6 is 8, and 4 and 8 is 12, and they all come down here, and they're different. 16 and 20, 10 and 26, 14 and 22, but they all equal 36, and I think that's really wild, because they can all be different too in these columns and in these slabs, and they all can be random numbers here in any fashion you want to put them in, any order, random numbers, anything. You put them all in here, they all come out equaling the same, which is the resulting output number 36. And I'll just rush through these real quick. Here's another one. You can freeze this if you want to see this to make sure it's right. Here's another one. Now these are the plus signs. I've only did this with addition, but there's other arithmetic operations, I believe. 1 plus 2 is 3, 2 plus 2, and it goes, and you can freeze this to know that this all is 19. These columns are the same. These slabs are the same. Whoops. These are another instances. I just put the plus signs in there, the addition signs. These are some more addition signs. Now this shows you can put a 3 by 3 by 3 array of numbers in the inputs, and that'll give you this would have 27 numbers, this would have 9 numbers, these slabs would have 9 numbers, these columns would have 3 numbers, and you'd have a single number here again. And if you could freeze this, you could tell that they're all correct. They're all the same number. These are 3 by 3 by 3 array, 2, 27, 9, 3, and 1. And so now I'll attempt to create my own, and I'll show you just how easy this is if I have the time. 1, 2, 3, 4, 5, 6, 7, 8, 3, 12, 7, 14, 6, 9, 10, 8 up to 11, and then right here. Oh, I forgot this one, slab. 5, 11, 5, 15, then these slabs, 16, 20, just right here, 16, 20, 15, 21, and right here, 10, 26, I believe. And all this is, it equals 36. You'll find out 1, 2, 4, 3, 5, 7, and 6, and 8 should be 36. So that's how quick and easy that can be for this matrix type. Well, thanks a lot.